Good morning, everyone. Thank you, Yasmin. Thank you, obviously, to the staff of Marcus Oldham for inviting me down. Like many of my colleagues working in precision ag, we certainly know where the bodies are buried. I mean, this discipline's been around since the mid-90s, and it was all spawned from the very simple fact that we could get GPSs, global positioning systems, and stick them on harvesters, and the rest is history. What I'm talking about today is virtually unrecognisable when you compare it to the heritage of precision ag from where we came from. In terms of my background, don't be horrified, but I'm a plasma physicist. I have no background in agriculture whatsoever, except for the fact that I was born and bred on the Murray River, and used to love knocking around farms and always wanted to stay in agriculture one way or another. That's once I became a fighter pilot, which meant I had to get a science degree, which meant I forgot about fighter pilots, and then I became a precision ag person. So it's been a really windy journey. And there's a salient point in that. The fact is that agriculture today demands things of people that don't just have a background in agriculture. So if you think perhaps that you're doing agriculture and it may not be yet turning you on, or there's dimensions of agriculture which you want to avoid, believe me, there's dimensions of agriculture available to you that we didn't even think of 10 years ago. So I want to talk about smart farming. This is what precision agriculture is today. SMART standing for sustainable, manageable and accessible rural technologies. For the last 5,000 years, farming was really about the production of two commodities, food and fibre. And of course, with the global fuel crisis of the 70s, last century, then of course the pressure was on, can we produce fuel on our landscapes as well, biofuels of course. And then of course when we got to the 1990s with the various discussions, for example Kyoto, all of a sudden there was a fourth commodity that was being talked about in the context of farming, carbon. And now of course there is another one, a fifth byproduct of farming, which is tradable, which can make money for people and which can make a difference to the way we farm, and that is data and information. And increasingly now we're seeing that being considered and indeed used in the marketplace as a commodity. So there are so many dimensions of farming that require a technology component over and above the production of food and fibre that offers enormous rafts of opportunities for people in this space. And what I've got there is a landscape of one of our farms in the New England. I'm from the New England region. For those of you unaware, that sort of sits between Sydney and Brisbane, but about 100 kilometres inland. We're up on a plateau about 1 kilometre off the deck. And it's predominantly sheep and beef country. But when you look at a farmscape like that, you've got the feed base that supports your animal production, you've got your water management, you've got your soils, you've got your remnant vegetation. And all of these sorts of assets, if you like, on farm can be supported by data generating technologies. And I'm going to give you a bit of a whirlwind tour of that, just to give you a sense of what's going on. I'm not going to talk about precision ag in action. That's where people like Andrew Whitlock and the PA people come in. They are a wonderful example of a smart services sector that's self-sown and growing in support of the demands of agriculture today. I'll be talking a little bit about some of the source technology that feeds into it. And so hopefully we've got the mix right for this morning's combination. But I did want to throw a few slides in there for those of you in the education sector, because the way we teach agriculture, the way we do research in agriculture today is totally different to what it was 15 years ago. We run, for example, a smart farm, as Yasmin mentioned. It's about 3,000 hectares of farming country. It's a commercial farm. It's got improved pasture, native grasses, scattered woodlands, tiger country way over the back. And that serves three objectives for us as an educator and a research provider. First of all, and absolutely foremost, it is a real functioning landscape from a farm. Now, you are sitting on a wonderful asset here at Marcus Oldham. You've got this beautiful open land. When I came in on the taxi this morning, the first thing I saw were those glowing pastures down at the bottom there. Every place should have a smart farm. It's a real farm. It's our context. It's your context as well. You've got the innovation centre dimension. You've got the ability to bring people here and inspire them about the technology of farming and the practice of farming of the future. And they can look out the window, and indeed you should be gazing out the window. I don't quite know where the blinds are down, and seeing exactly where you are. Don't forget for a second where you are, and we've got exactly the same. You will have, as we have, an enormously connected landscape. The future of farming is a connected future, and I'm going to talk a little bit about the challenges and opportunities of connecting up our farmscapes for our farmers to get the best from them. On our farm, we've had to run fibre out there. We've got fixed wireless NBN, satellite NBN, as well as a number of sensor network technologies around, because it's about generating information, actionable information from the landscape. And of course, it's about you, the students. So every piece of information that comes off our farm, for example, as could come off this landscape here, in the classroom, in the work packages, assignments, accessible actions for students of all ages. And I think there should be 137,000 smart farms around the country, not just one. So hopefully we're at the beginning and not the end of the deal. It feeds into many of our teaching courses, ranging from the traditional rural ag science dimension through the environmental science, into our teaching degrees, and of course into our science degrees. And at the end of the day, it's about the outreach. It's about demonstrating the role of farming futures and the technologies that underpin it in the business and lifestyle of our existence and our farming existence. Now, the thing about precision ag today is it's conducted all over the place. I mean, Australia has a wonderful global heritage in undertaking precision ag. My group alone, I'm privileged to be part of a team of almost now 20 people involved in projects. We've got projects going on at 22 locations around the country, and we're not the only ones doing it. It is an absolutely wonderful time to be in the area of future farming. We are knocking back work. We are knocking back work for the first time in my working life. And so will you when you move into the sector. And Andrew, for example, no doubt will be telling you about some of the career options that are out there, because it is truly an exciting space to move in. And when it comes to education, every Australian farm is a source of some piece of information that is really valuable to our learning experience. And so we're part of, and hopefully you will consider being part of a national and hopefully a global smart farm learning hub, because we're all connected ultimately. We have data and information that can be exchanged, and more importantly, we involve industry in this. That's a real part. Well, to get back to precision ag, for a start, in the old days, unfortunately, people used to think ag was for dummies. If you didn't like physics, chemistry, biology and maths, do ag. You'll be right, it'll get you through. No way. Ag requires the smartest, most tech-savvy people that we can get, and hence you are here. Okay? If you look at it, you've got your animal science, agronomy, soil science, but you've got engineering, chemistry, statistics, biology, physics, computational science, robotics, autonomous systems, intelligence systems, to name a few. Okay? Farming is the ultimate STEM, science, technology, engineering and mathematics in action. And that is why even plasma physicists can get a very satisfying career working in this space. There is nothing quite like it. Because at the end of the day, I look around the room, you've all got your smartphones, you've all got your social media, you've all got a totally different way of looking at the world. That's the way farming has to evolve, because you are the farmers of the future, not us. There's no point us trying to smack round pegs in square holes. The way we farm has to evolve to suit you, the farmers, as much as you, the farmers, have to evolve to suit the landscape that you're going to work in. So let me give you a bit of an example of what's happened in the last 15 years in the ag and the ag tech sector. The use of satellites, overhead satellites, to keep an eye on the ground below us has been around since the 70s. And in fact, satellite remote sensing, as we call it, got the interest of ag way back in the late 70s, early 80s. But the industry was burnt by it because the satellite systems were clunky. The spatial resolution on the ground was too coarse. You couldn't see small enough detail. And the delivery mechanisms of information was useless. So people bought into it and then got burnt. And we've spent the last 20 years reinvigorating, if you like, the confidence of the industry in technology, because satellites now are smarter. They see much smaller things on the ground. There are many more of them up there, and the delivery systems of information are now quite schmick. You can get satellite data off your provider within days of acquisition and get access to reliable weekly products. And let me give you an example. For example, a colleague of mine, Andrew Robson, is doing the yield forecasting for every one of the 30,000 sugar fields in the country from Armidale. The satellite data is downloaded and delivered within 2 days. Within about 2 other days, he's now processed every crop into a yield forecast, which can then be cookie cut down and delivered back to the growers via either a smartphone. If you're into livestock production systems, pastures from space, was the earliest foray into monitoring our feed base for our animals. The use of MODIS satellite, 250 metres is the smallest object on the ground they can see. They pass over twice a day to collect imagery and to convert it to an estimate of pasture biomass. The trouble was the pixels were too large, and it took about 3 weeks to get access to the data. Now you can get the data downloaded again within days. In fact, you just get delivered a weekly composite image. So twice a day you get an image taken of your place. They're all stacked on one another, and those 14 images are used to effectively recreate a cloud-free image for the week of your place. That can now be back-ended with an MLA, Meat Livestock Australia, stocking rate calculator, so that you click on your pastures, you estimate your biomass, and you can even do stocking rates modelling. You know, if I've got this particular paddock, that's my feed base, it's tracking like a particular year, that's my estimate of growth over the coming season. You know, if I want to put 300 head on, how long can I do it to maintain my biomass intervals? Or if I want to march, cattle on for 3 weeks, how many head can I cram in there and still meet my biomass grazing intervals? So at the end of the day, this stuff's deliverable now. It was easy enough for me the other day just to sneak on and check out Liveringha Station, which is in the Western Kimberley. It doesn't matter where you are. If you've got a farm and you put it on the system, you've got access to the data. Now, it's a very slick delivery system. The business models are right. It costs about maybe $500 a year to have your farm running on the system, and you just go on and access the data as you need it. Of course, it sounds easy when you say it fast. There is a learning curve, and what you get back is what you put in. You calibrate it for your farm, but there are tools and processes to help you do that. And of course, if you've got access to mobiles, and I'll come back to the telecommunications challenges shortly, then it's back to you on your phone. It's more than just production in terms of animals and plants. It's about the sustainability of your production system. And there are remotely sensed products, satellite-based products, that allow you to track your production system over longer periods of time. For example, the federal government is now unlocking what we call the data cube, a heritage of satellite imagery dating back to the 1990s. So there are tools now to look at your ground cover, for example, and you can check the trajectory of your ground cover over long periods of time to know that your season by season management is being done in a way that is maintaining or improving your ground cover, for example, or your biodiversity indicators. And that's a really important part of managing your landscape. Production this year, sure, but remember, you're in the long game to keep your land healthy, and obviously, where possible, to keep it improving. And this data is available, you know, so this is another dimension of the use of satellite remote sensing. Carbon, that fourth commodity I mentioned earlier. You know, with the data that's available to us now as farm managers, we can start wargaming issues around carbon. For example, on our farm, we know we've got approximately 260,000 tonnes of above ground carbon. How do we know that? Well, there are international protocols that can be followed using commercially available satellite products to allow you to calculate that. You can even wargame around, well, what if I change some of my management practices? And for example, there's about 140,000 tonnes of extra carbon that we can put back into that landscape by changing the way we manage. And that's wargaming based on that data that you collect using the remotely sensed products. And if we're in the remote sensing, of course, we've got the new kid on the block, which is the drones. Now, how many of you have got a drone? Yeah, that's right. It's okay, stick them up. Okay, cool. And you know, it's probably highly illegal the way you're using it, but that's okay. Because come 1st of October, you can be free again. After 1st of October, every Australian farmer will be able to legitimately operate a sub 2 kilogram drone, a little like DJI Phantom type device, on their farm for the purposes of farming without any form of legislation or regulatory requirements at all. So you're okay, but you have to fly it within line of sight, which is a 1 kilometre radius. You can't exceed 400 feet above ground, and you're not allowed within 30 metres of a person otherwise unconnected with your operation. So bearing that in mind, what can you do with drones? Now, drones, like any new technology, gets thrown up as the silver bullet. And in our case, people think drones will be the silver bullet of farming. There are some really impressive things that you will be able to do with your drone to help you in the business and lifestyle of farming, and you're going to hear a little bit about that later on this morning. But let me just give you two examples. We've got a little DJI Phantom, $1,000 on the internet, right? Runs with a little free-to-air app on the phone. What can I do with that if I was a farmer? Well, certainly you can scoot around and maybe check your troughs or your cattle. Now, people think, well, if you can't fly beyond line of sight, what's the point of having a drone anyway? Because you can see it. Well, yeah, but what if you've got to open 6 gates to get to the edge of your line of sight? So a drone's quite neat. Check the trough. You know, is the indicator still standing up in the tank up in the top corner? And we have farmers that we work with that do just that sort of thing. You know, workflow sort of related activities. It just keeps their day simple. But you can push them a little harder too. Here's an example. Using one of the free apps, drone takes off, you program a set of photos that the thing takes. Here's a 40-acre parcel of land. The drone's literally flying that transect I've just mapped there on the left-hand side, on the western edge of the farm. The images are looking to the east. 4.5 minutes of flying. The app actually lands the drone. You don't touch the thing. It just lands it in front of you. The minute the drone shuts down, up on the cloud it goes. 6 minutes of processing time. Then you end up with a 3-dimensional image of your section of land. Now we're interested in that because you can then go on your desktop at home and measure the dimensions of every tree. And for example, in that particular paddock, which is about 7.5 hectares, there's about 38 tonnes of above ground biomass carbon in that paddock. The pasture biomass underneath is another thing that could potentially be estimated. So you can put serious science at people's fingertips by a very simple device and flying within the legal requirements that's available to us at the moment. But of course, you don't have to look very far. In the 1990s, I had an airborne video system that was 21 kilograms. It had 4 cameras on it, and in fact, I cut my teeth flying it all around the country to the north here, over all the grains crops, taking colour and infrared images of crops to look for variations in the field. And it would take me a whole day just to basically load up in Wagga, fly down here, collect the data and fly home. Now you can do it from the boot of your car with a drone. So the Parrot Sequoia, for example, is a classic colour infrared imaging camera system. And look at the size of the thing. You just hold it within your hands. Tiny little thing. So colour infrared imagery, which used to be something special for the industry now, is it can be in everybody's glove box. And of course in the colour infrared imagery, that pink colour, that's the very strong near infrared reflectance coming off the crop that tells you lots about the vigour. See the wheel tracks, see the variations in the biomass there. You can do the same thing on this sort of quality data as we used to have to spend days doing back in the lab when we landed our aircraft. Converting the imagery into a form that allows you to really showcase out the stress or the vigour differences in that particular crop, which could be ultimately linked to yield and quality. But even now you can do height measurements. When we take a photo of a crop or a pasture from above, we can explain about 70% at best of the variance in that biomass. In other words, that you'll only ever get plus or minus about 25% in terms of your error in your ability to predict biomass just by the way it looks colour-wise. But if you bring height into the dimension, you can get up to the 80-85% explanation levels. And this can be done using the same drones. They just take lots and lots of images and they effectively do stereoscopic imagery work that we used to use with those weird goggles. It's all done in the blink of an eye. And all of a sudden we now have serious tools to get us to our biomass, which is a key indicator of crop and or pasture production. The Internet of Things has an enormous future with farming. You know, there was a review done about 5 years ago that suggested that the Internet of Things, that small connectable devices around us, was going to contribute some $19 trillion to global GDP by 2030, which is enormous. But when you read the report, farming didn't even get a mention. Yet farming is the ultimate application of the Internet of Things because we have massive landscapes and we want to know what's going on with our plants, our soil and our animals and our assets. So moving towards in-farm connectivity options is a really important thing. Once you've got your landscapes set up with a communications network, which is a real challenge, but there are some really exciting options I'll touch on shortly, then you can do some interesting things. So I'm not going to talk about animals and pastures and crops. Trees, for example. Here's an example of a device you plug into the side of a tree that measures the flow of sap up and down the tree, about the size of your hand. Now that is the daily sap flow records of that particular stringy bark tree dating back to October last year. That's the blue and the green zigzags. Every day the tree wakes up, pumps water up, goes back to sleep. The red marks are the rainfall events. So I've got a soil moisture probe on the farm ticking away as well. as you come out of winter, in our neck of the woods, winter's dry. So the deep roots, which are the blue zigzags, are the only ones pumping water. That tree's pumping out about 30 litres of water a day during winter through the deep roots. But as the rainfall kicks in around November, December, then the shallow roots, which is the green zigzags, are now starting to kick in. And by the time you get to our peak growing period, that tree's pumping about 70 litres of water a day out of a paddock. Now we've got 750,000 trees on our farm, pumping out about 70 litres of water a day. It's a lot of water going out. But bear in mind, if you have a giant American redwood tree, the real monsters up in North America, a single tree pumps out 3,000 litres a day. That's one tree. So there's an enormous amount of water that gets moved around. But there's your ultimate soil moisture probe. Now, you connect things up on the farm that are already working for you, and imagine what you can start measuring. So, interestingly enough, when I did show this data to a Wimmera farmer who was up there about 3 weeks ago, he said straight away, well, there's my soil moisture probe. I've got my top metre, and I've got my next 3 metres. That's really handy. So maybe that's one less tree that will get dozed in the ground. But it's more than that. Soil moisture, of course, cuts across a whole range of activities of farming. When to sow, when to plough, when to put your animals on, how long your pasture's got to run before it runs out of legs, lots of little things like that. You know, we thought we were the cheese when we could put a single soil moisture probe on our farm hooked up to a telemetry system, about $5,000 a unit. Well, now we're moving to a future of soil moisture probes that are $100 a pop and that will connect to your phone. So sure, on our farm we've got 100 soil moisture probes ticking away. But that's a $500,000 asset. No farmer wants $500,000 tied up in soil moisture probes. But like I said, in the 5 years since we've had that system running, the technology's dropped an order of magnitude. And the connectivity challenges have been improved vastly. The phone can run them. So we have a living and breathing soil moisture map. But why would you want that anyway? Well, interestingly enough, if you can monitor your soil moisture and you can bring in the sorts of remote sensing technologies that we've been banging our head against a brick wall for the last 15 years, you can actually very accurately predict your plant growth. Here's an example of a tall fescue plot using the soil moisture data and the highly localised measurements that you can get from an automatic weather station. We can estimate the pasture growth within 2 kilograms of biomass per hectare per day. So the algorithms, the maths is quite straightforward, and it's been around for years, but we never had the sensors to actually bring it to life. So to be able to monitor pasture growth, for example, to that accuracy, almost too good to be true, that's an enormously powerful tool when it comes to me scheduling my rotation, for example, of my stock, or my stocking densities. You've got the horticulture industry now waking up and saying, wow, every one of our avocado trees needs to be hooked up. We want to monitor every tree. That is our measurement unit, the tree, not the orchard. So technology that you plug and play in trees will effectively light up the whole horticulture industry. Every tree will be managed for their own symptoms. But of course, vision is another thing. The camera systems that we take for granted in our warehouses, in our shopping centres, these should be all on farm. But transmitting vision across farm landscapes is very data intensive. You can't use simple telemetry systems to do that. So the only option we've got at the moment are mobile phone modems on cameras, and that of course means that you've got to have mobile connectivity. But there are people, and here's an example of a business I'm aware of, I'm not associated with it, but just to give you an example, RM Tech, who devised vision-based systems that work on the noise floor that are designed to transmit imagery over long distances in small packets. So every chook shed should have them in. Okay, every chemical shed and machinery shed should have them in. It's easy for me to check what's going on this farm because I can tilt, pan, zoom the camera or go to preset settings, check the simple things. For example, we have a camera setting for the doors in the shed. Did the last person that walked in the shed close the door? Are the feed bags stacked up off the ground so the mice don't get in it? Little things like that which could make a difference. So vision systems are going to be an important part of our farming future. But for example, consider the way free-range chickens work. Now the decision's made, you know, every girl needs a space. So every chook gets a square metre. That's 100,000 birds per hectare. That is what free-range chickens are going to have to comply with. Now imagine a paddock that has got 100,000 Isa Browns pecking away on it. How do you work out the sick one? Well, there are vision systems that will do that, that will monitor 100,000 fluffy blobs moving around and work out which one of those is acting unlike the others. Keep an eye on it, and they all move around. Now, this is sort of anti-terrorism type technology, people acting suspiciously in crowded places. Sure, but this technology has a really important role to play in our poultry industry, for example, or in our feedlotters. Pen riding is fun. If you're on a horse, checking out the animals in a feedlot on a horse, it's great fun for the first day. So vision systems are an option, and they are being seriously considered by the sector. So that's another example of Internet of Things. Wild dogs cost our sheep industry about $25 million a year in lost production. So sentinel camera systems that are out watching your fence lines. See a dog, for example, this guy here that Greg Fowles on up on the left there talking to the Honourable Minister, he's a computational scientist. And he's been working with a team on basically feature-based recognition. That is a dog, sure, it's not a possum or koala, but it's got all the profile of a wild dog. It's been here before, it's heading this way, handshake it off to the next camera down the road. So this is sort of security monitoring systems, but why not? You all can imagine the heartbreak of stepping out in your place in the morning and seeing half a dozen gutted sheep lying around your paddock. It's not a good thing. And this technology will play a role. And it comes with it enormous demands on data processing, analytics, computer vision systems and telecommunications. Quad bikes are still one of the biggest killers of Australian farmers. 280 farmers killed in the last 8 years. Generally due to suffocation and crush injury. So 350 kilos lying on your chest, how long can you handle it for? So why don't we have a national scheme of quad bike monitoring? There are technologies out there. UC is an example. It's actually run out of a farm west of Charters Towers in Queensland. These are small devices that plug onto your quad bikes and track them around. You set the thresholds of speed of the number of Gs you want to pull on a turn, and the alarms come flooding in. Now, admittedly, the farm staff on our farm, I think, just love waking me up at all hours with this damn thing, and I just keep jacking the threshold up a little higher. As a physicist, I know that if I set it at the speed of light, they'll never get it. But I wouldn't put it past them for trying. But what I'm getting at here is that throws up challenges around data analytics, for example. How do you fingerprint behaviour on a quad bike? Everyone rides a quad bike differently. Okay, what I would consider life-threatening behaviour, my young 14-year-old boy wouldn't get out of bed for, right? So he wants to get there and give it a good caning, and he can do it competently. But I want to know that the thresholds are set for the right people. So there's an enormous amount of analytics that need to be brought in. And simple things. There's a GPS tracker on that quad bike. It's chugging around the road. It's just been doing a bit of mustering up the top there past our farmhouse. But every now and then the GPS drops out, and see how the point suddenly jumps over there? Well, that quad bike almost exceeded the speed of sound for those 3 measurements to get there and back, and it is purely a GPS noise problem. So we need to smarten up the GPS technology as well. And everything that we're talking about is going to come down to data and analytics. And, mathematicians and computational sciences are going to play a really important role in the future of farming, just as much as you will be in your particular chosen areas. If you want to be out in the paddock, your agronomy, your plant agronomy, your soil science, your animal science, just as much as you're going to play an important role in it. And just to give you an example, in the mid-1990s, precision ag got kicked off when we put GPSs on harvesters and monitored the yield coming in on the harvester. Now, if you take tracking technology, which is prototype, and you take walk-over weigh technology, which is still finding its way in the industry for the livestock industry, you can create a yield map for our livestock sector. Now, that took a lot of work to create that, but just like any yield map, there's an order of magnitude between the low performing regions of a paddock, here 20 kilos per hectare per year, and annualised weight gain for our sheep, up to 200. But when that comes online, an entire sector is going to wake up and go, precision ag, we need it. All right? And you're going to be in the right place at the right time to do that. And just to carve off on the last few points, I just want to talk a little bit about where precision ag started and where it is now. About 80% of Australian farmers are using some form of precision ag, generally around GPS guidance. The use of GPS on ground to guide our machinery so we can maintain our rows using controlled traffic or permanent wheel tracks. Just for argument's sake, for the base station sort of GPS purist, there's the wheel tracks of the RTK base station, that's the wheel tracks of the satellite only system. As our Japanese counterpart said, we didn't kill any rice. Okay, but of course our farming future, as I opened with, is a connected future. Now, unless you've got good mobile coverage on your farm, or you've got access to NBN satellite to your farmhouse, then how else are you going to move things around? Well, there are some clever tricks coming up on the horizon which I thought it's worth just closing off on. There is a global movement afoot to get an open sourced communications framework set up that will effectively allow people to plug and play things that can be developed on Raspberry Pi, Arduino, whatever. Now this is sort of IEEE speak here, but at the end of the day, we're talking about sensors and communication technologies that will send small packets of information over large distances. So you can have your gate alarms set, you can have your trough sensors going, you can even have your tags on your cattle or your plant and soil sensors ticking away on the ground. And it's called LoRa. It's effectively long range, low energy, wide area network stuff. But what's exciting about it is there moves afoot to create communities. So in other words, you can have, because these things can transmit up to 60 kilometres, you could have half a dozen farmers with all their sensors on sharing one gateway. And one gateway means one data plan, one bill to pay. Right? And we're talking sort of mobile phone data plan sort of bills. So that's really quite exciting. That's something worth mentioning. There are also people working on what I call extraterrestrial solutions. In other words, for example, there's a group called Myriota that I'm aware of. Now, basically, all of the big container ships that move around the globe are constantly tracked by satellites. And all of the big shipping container companies know where their ships are, how fast they're moving, what their fuel state is, the direction they're heading, and so forth. And that's done by a constellation of low Earth orbiting satellites, about 800 kilometres off the deck. And they just go around, there's a mob of them, and they just go around and hoover up the information that's been stored on the ship since the last overpass. Those satellites are effectively underutilised enormously. So a group like Myriota have gone and bought bandwidth on these satellites, so now that these satellites are available to hoover up stuff off your farm boxes that are ticking away. Now you've got to bear in mind where the real clever thing is, these satellites can hoover up data from 100,000 devices at any time. So it can be all over the field of view, and these are 800 kilometres high. So these are the sorts of things that will feed off your farm weather stations or your soil moisture probes that you've scattered around your countryside, or your plant probes. So this sort of stuff will bring data to our fingertips, and it requires no on-ground infrastructure, telecommunications infrastructure, other than an interface box, which I'm told is about the size of a credit card. So, but keep your eye on that dimension as well. And of course, we've all got phones. And if you've got mobile phone connectivity, then you can play a role in the smart farming revolution. There are apps galore. I think there's more than 300 farm-related apps now for iOS and Android type systems that you can access. Everything from obviously the weather, but to business decision making as well. But also now apps that are appearing around the actual physical measurements you may want to take on your farm. Here's an example of an app that's being developed by the Cooperative Research Centre for Spatial Information and Meat Livestock Australia. A small handheld device which you wave over your field and pull a trigger gives you the red and near infrared optical measurements of your ground. The phone app will convert that to a biomass, knowing where you are, what species you're looking at, what your clover mix is and so forth, which is fine, it's a little calculator. But at the same time, when you run that thing, it also uploads that information, just the information only, so this is not the sort of the census sort of stuff we've been hearing about overnight, just your information to make the algorithm smarter. So all of a sudden, you, the farmers, are contributing to the quality of the algorithm that you will then use back on your own farm. So sensor technology meets smartphones, meets crowdsourcing. I mean, we have 137,000 farm businesses in Australia. What a wonderful source of expert knowledge that could be brought into some of our smart farm tech to make it smarter. But of course, to get wrapped around the axle, which will save a lot of questions, let's talk quickly about the telecommunications challenge we've got. 99% of Australians have reliable mobile phone access, so relax. But 30% of the country is covered by reliable mobile phone connectivity. So don't relax, because guess what? All the farming is being done is in the other parts of the country. So we know we've got massive telecommunications challenges. I think the message has got through. We just needed to roll out quicker. So we know that's a challenge, but as I said earlier, there are some clever solutions appearing in the marketplace that will get us around this bottleneck. And of course, we have Sky Muster 2 now up in the air safely as of, 2 weeks ago. So it's just a matter of turning on the various cells and finally connecting up our farms. But of course, the thing that really sort of gets up my hooter a little bit is that when we're talking about broadband coverage, it's back to the farmhouse. What we need are these. We need Jeeps with a big fat satellite dish on that we can go park over at our yards or out between 6 harvesters and run Wi-Fi hotspots and have a direct link to SkyMaster. Now, interestingly enough, these are starting to appear for demonstration purposes only, but you never know. You may have another bit of kit to make your ute look even cooler. Who knows? Okay, thanks very much.
Thank you, David. Well, you've certainly got us thinking there. There's a heck of a lot of stuff out there. Now, look, we've got time for a couple of questions. Michael, could we please grab a couple of mics too? So, has anyone got a question? Ian, we'll grab a mic as well. We've got just one down here.
Thanks, David. Fantastic talk. I've got 2 very quick questions. Have you got MOOC, massive online open education, to get everyone up to speed on that? And secondly, I noticed in your network, you've got all this data feeding in, you've got nothing on what ends up on the plate. So we need to connect the kitchen and the table back onto the paddock. What's happening there?
Okay, first answer. So I assume in your question about MOOC whether we as an institution are involved in that, and we've certainly worked in that space like everyone did 5 years ago. We jumped on it. In a way, we've got MOOC 2, which is where the Smart Farm Learning Hub comes in. So in other words, we're creating data as an example off our farm, but we would like to see data being created on every farm or elements of some farming practice of excellence. And like we're doing with our system, those are then being made available through login access and then teaching packages. So we're actually developing the teaching package scaffold that goes out into the end user. So for example, through the Smart Farm Learning Hub, we've got the universities involved. So some of that precision ag data goes into the precision ag teaching content. More importantly, we're interested in pushing it into high schools. And for example, even the notion of developing up school packs, school sensor packs. Every school that has a farmlet on their school should be making that farmlet data available to a school down the road that hasn't got it. You know, in the smoke. Our poor city cousins, they really struggle because they have no idea what they're missing out on. So what I'm thinking here is that MOOC 2, which is around, Smart Farm Learning Hub, not our smart farm, but everyone's smart farms, elements of excellence here, for example. That could be the part of, could be the elements of a shared learning resource for everybody. You can have free access to our data if we can access some of your equine data, for example, coming off some of your horse trials, for example, or coming out of a robotic dairy. So I know it's not a direct answer, but in a way it'll be MOOC 2, but we're coming from the ground level. Now the second question, which I think I've just forgotten. What was that one? Just give me a primer.
Food.
Oh, food. Yes. When we started Precision Ag, everyone was talking about this is about from paddock to plate. Let's get what's going on in the paddock to plate, but it's actually not. It's about from plate to paddock. Because now that we have a connected consumer base, we farmers need to be listening directly to our clients, the consumers, about what they want and how they want it. So in other words, it starts at the plate and ends back in the paddock. And the notion of connected farming, smart farms, big data, supply chain, whole of life or whole of supply chain monitoring is actually shaping up to be all around the plate back to the paddock. And so guess what, farmers? We've got one mouth and 2 ears. We used to think that the consumer wanted to hear about what we were doing. Actually, it's not. We have to hear about what the consumers want and then start from there and then work in that direction. So what we do in our group, you have to bear in mind that my group's business is research income. Now, I know that sounds awful, but what I'm getting at is we get asked by industry to evaluate technologies and processes and then create an appetite for that technology and process in the marketplace. So we don't deliver actionable information as a group per se, but all of our R&D, which is industry funded, 100% industry funded, it carries with it a stakeholder base whose principal role is to ensure we're kept honest in what we do as an R&D provider, but also what we generate is exactly palatable to what they need. So yes, in fact, you don't survive in that game, but you're asking, well, where is this systems now to help us manage farms? That's why everyone's talking about big data, because at the end of the day, looking at a yield map or a soil pH map, you know, the neck-top computer and the gut server really kicks in and says, oh yeah, this is what we should do, and we do it. Our challenges at the moment is that artificial intelligence is no substitute for natural stupidity at all. And that's the problem. The real challenge is in making computers and machines think like we do with our heritage of experience. We're stupid because we make mistakes, and we learn from them. So how we look at a piece of land, how we understand how it performs, and how we convert the ones and zeros that can come off that land into the thing that my father would have done, or you experienced farmers would have done, or that you would do now even with your knowledge of the land, that's a real challenge. And that's why big data is all cycling around the media, and in the last 5 years we still don't have a solution, but we're getting there. So all I'm saying is I can't answer your question, but we're all pushing hard to get there, to be just like you, and that's the hard bit.
David, on your smart farm, you obviously have quite a range of diversity of herbage and things. I would have thought virtual fencing would have come into that pretty... I do admit that it is illegal because of welfare problems in Victoria, but surely New South Wales is a bit further ahead than us.
You're going to say, are we a little more backward in our animal ethics? Well, look, here's the deal. We've actually done some virtual fence trials. Interesting, and I'll tell you a quick story. Kit up and it was all animal ethics approved. Kit up an animal with a virtual fence, walk along, ping, bang. What happened? Okay, go back about 3 times. After 3 times, they pick up the ping and they'll back away. But the most important lesson we learned, we created the technology in about 3 weeks, because you can do the stuff with stuff you buy off the internet half the time. What we learned was, though, is that when you started belting animals for no reason, according to them, you know, all of a sudden that rock became the virtual fence. And then you take that mob of cattle and you move them up into a granite hillside and they're completely lost. So in other words, virtual fencing, everyone gets. You know, there's 5 million kilometres of fencing, $5,000 a kilometre. That's a $25 billion asset that's got to be recycled every 20 years. We get it. The technology is actually there to deliver it, but the animal behaviourist dimension has not been understood. Now, there's a large project just been funded under the Rural R&D for Profit out of the Ministry for Ag on virtual herding, and that will pick up where CSA left off in virtual fencing technology. I think AgriSense are involved, and we're going to hear a little bit from AgriSense today, which is really exciting. I hope you're going to talk a little bit about that. There's some really exciting developments going on in that space, literally as we speak. 5 years ago, I said virtual fencing was still 10 years away. I think that in terms of an operational sense, I think we're a lot closer now, and we'll hear about it. But there are still some significant challenges around the animal behaviour dimensions to get our head around. But like any technology, it's about using it sensibly. And there are some really interesting options that are available to make it work. So we've done a little bit of dibbling with it. There are groups that have done a lot of work on it, and you're going to hear about it later this morning.
I know it's based on the beef and sheep industry and all that, but what advantages could it have for the thoroughbred studs in the Hunter and Victoria and all that? Okay.
Well, the one experience we've had recently with some of our technology was in the tracking. So, for example, we were tracking around mares. We were looking at maiden mares versus experienced mares. This is just an example. What we found was that when the maiden mare has the first foal, she's really fussy, really nervous, like all first mums are. Right now, a maiden mare will walk about 14 kilometres a day, fussing around the foal. The experienced mare walks about 7. Now, straight away, that information, and when you look at the maps of how they walk and where they behave, straight away, let's rethink the way we fence off our enclosures. We've also done work tracking these horses around and their behaviour and their exercise metrics around paddocks of different sizes. You know, what is the optimum size for a horse to be able to graze and naturally exist and kick up their heels and run around and do whatever? What is the optimal size of that, bearing in mind the limited space available and the number of horses you've got? It's amazing when you start recording information like their tracking behaviour, their physical behaviour with accelerometers and how they move, then you can start thinking about designing of your paddocks. The accelerometers on ears and on legs can start giving you subclinical disease detection options or medical detection options because they're starting to behave differently because they're feeling uncomfortable. And that's just with the horse themselves. That's without even thinking about the feed base. So, you know, in those 2 examples that I just cited, they were short projects we did. And everyone looked and said, we get that, let's have a part of that. Now we're waiting for the cheap and cheesy technology to turn up so that everyone can have one on a horse. So really exciting options. Thank you.
Just hang around there for a bit. I've just changed my... Look, I'm mindful that we've just gone over time a little bit, and David does have another flight to catch back. So what I'm going to do is say thank you very much. That's there's obviously probably more questions out there, and there will be a chance at morning tea. But just in case his taxi turns up, I'd just like to give him a small token of our appreciation for him. Thank you.